I came across this demo a little while back when I inherited a new classroom. This is a really old demonstration, and actually you can see kind of get an idea of roughly how old the demonstration is by the state of the paper here. It's all yellowed, and based on the state of yellowing in the paper, I'm guessing that this demonstration is about 30,000 years old. Give or take like 30,000 years. So somewhere in that range anyway. It's a really straightforward demonstration, though. This is just a plastic plate. And then I have also this metal disc that has a wooden dowel attached to it. And so what I'm going to do on this is go ahead and use a rabbit fur to charge up this little plastic plate. Get that triboelectric effect going here. So the rabbit fur tends to give away electrons. The plastic tends to collect electrons. So I get that nice and charged up. And then I'm going to bring the metal disc close to it. And I'm just going to set the metal disc down. And then I'll pick the metal disc back up and I'm going to touch it. Now what do you think is going to happen when I touch that metal disc? Well, if you think a shock is going to happen, that's exactly what I think as well, or what I thought before I tried this. But I find that there's no shock at all. Even if I kind of rub this around a little bit so I can pick the electrons up, I don't get any shock. And then I thought, well, this must just be busted. And I set it down and I touched it then. And I felt a shock. I thought, well, that's odd. So how come it didn't do it when I just touched it like this? And it did. I got another shock. I thought, wait a minute, hang on. Let me collect a little more charge here, and no shock. What if I try this again? Set it down and touch, and we get a shock. And then I pick it up, and I touch, and I get a shock. Now this was really surprising. Shock. 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 What's happening here is the disc is being charged by induction. So right now this this plastic plate, it has lots of extra negative charges on it, lots of extra negative electrons. And so when I push the metal plate on there, it's a really thin metal plate. So there's, it's a little extra space for the electrons to occupy, but not a whole lot, and they don't tend to transfer very well off of this plastic either. The plastic is a pretty good holder of electrons. And so when I pull this away, I might get a few extra electrons on there, and so maybe there's some transfer to my fingers, but it's not enough to feel. But when I set it down like this, I've got all these electrons on the plastic that are exerting forces on the electrons in this plate, so and on the protons as well. They're repulsive forces on the electrons. So it's trying to push these electrons out of the plate, but there's nowhere for them to go until I make contact with it. And I get a shock because suddenly there's more space for these electrons to occupy, and that's inside of my body. When I pull this up, when I put my hand down and take that extra charge, and then when I pull this back up, now that force from the plate has pushed a bunch of electrons out of this plate and into my body. And so now this thing has fewer electrons than it should have, or fewer than would be required for it to be neutral. So when I touch it again, I get another shock because now I've got electrons in my hand that are moving in here to try and equalize that electron distribution again. So more electrons in my hand, fewer in the plate, so we're going to have a net movement of electrons in this direction. So this is a process called charging by induction. So I feel it a little bit here, nice big shock when I do it up here. Charging by induction, where we actually don't even have to have the metal plate make contact, and it's a little tough to see, but I'm not making contact right now. And I feel a little bit of a shock there, and when I move it far away, I feel a little bit of a shock there as well. So charging by induction, one way that we can charge up this plate, and doesn't even require contact. It works a little better with very close distances like that, but doesn't require contact.